Hi! I want to start by saying hi to my TA and Professor Nez. Unfortunately, there hasn't been any crystal growth. I'm in the Monday lab section from 3:30 to 5:50 p.m. and they were set down on my desk at about 9 p.m. on Monday evening, and even though I've been watching them super closely for the last 4 days, there really has been no growth, which you can kind of see from here. Even though the steps on lab archives seemed really long and complicated, it actually wasn't too difficult going about the entire process. The first step was dissolving around 1 gram of aluminum foil in potassium hydroxide to remove impurities, which was an oxidation reduction reaction. The aluminum is oxidized to the +3 state, and the hydrogen was reduced from +1 to 0 to form hydrogen gas. So the full reaction is 2Al solid plus 2KOH aqueous plus 6H2O liquid yields 2KAlOH4 aqueous plus 3H2 gas. After filtration to remove excess impurities with the Buchner technique, the alkaline solution of AlOH4 is clear and colorless. Sulfuric acid was added, which prompts 2 reactions. The first was an acid-base reaction where the H+ ions from the sulfuric acid neutralize the base to create a thick, white, gelatinous precipitate of aluminum hydroxide. The full equation was AlOH4 aqueous plus H+ aqueous yields AlOH3 solid plus H2O liquid. As more acid is added, the equation becomes 2AlOH3 solid plus 3H2OSO4 aqueous yields Al2SO4 3 aqueous plus 6H2O liquid, since the precipitate of AlOH3 dissolves to give aluminum 3+ ions in solution. At this point, the solution has Al3+ ions, K+ ions, and SOF2 ions as well. The beaker was then placed in an ice bath to lower the temperature, which is necessary because alum crystals are soluble in water at room temperature. Upon cooling, crystals of hydrated potassium aluminum sulfate are deposited, and the final equation was Al2SO4 3 aqueous plus K2SO4 aqueous plus 24H2O liquid yields 2KAlSO4 2 times 12H2O, which the final part of is also the aluminum sulfate potassium, which was deposited. Finally, the alum crystals are removed from the solution by vacuum filtration, and they're washed with a 50% ethanol, 50% diluted water, DI water mixture. This removes contamination from the crystals but doesn't dissolve them and allows for the crystals to dry more quickly. A saturated solution was created with the alum crystals and diluted water, which was then what was placed into the tubes, and within the next few weeks we hope to be able to see some growth. If we wanted to approach growing crystals of table salt, the process is actually relatively simple, and we would have to start by again preparing a saturated salt solution, which we could create by just boiling hot water until no more salt dissolves. We have to make sure that the water is as close to boiling as possible to ensure complete saturation. While doing this, it's also okay if undissolved salt settles at the bottom, just as long as none of that salt transfers into the crystal growing container. To create a mass of crystals, we first have to pour the saturated salt solution into a vial or another clear container and slowly allow it to evaporate. Crystals will begin to grow on the sides of the container. If you want to create a larger cubic crystal, you have to first create a seed crystal. To do this, you need to pour a small amount of the saturated salt solution onto either a saucer or a watch glass. While the liquid evaporates, crystals will begin to form. You can then select a single square crystal from the saucer or the watch glass. Now, to grow a big crystal from the seed crystal that you create, you have to pour the supersaturated salt solution into a clear container, still ensuring that none of the undissolved salt gets in. And after allowing the solution to cool, using a string, you hang the seed crystal in the solution from a pencil placed across the container. You have to make sure that the solution is saturated and cool so it won't dissolve the seed crystal. As we did in our own lab, we can cover the container with Chem wipe or some kind of coffee filter to keep out the dust. If you want to create a perfect crystal, it would be best to use uniodized salt and distilled water. A lot of the information was found online on sciencenotes.org, Salt Association, but the steps are in principle kind of the same as we did in lab, just kind of creating a saturated solution with the salt and then kind of allowing the water to evaporate. The crystals will then begin to form. Another cool type of crystal that you can create is rock candy, which is very popular with like the elementary school generation. It involves entirely different materials in both the processes of making alum crystals and NaCl crystals, but the approach to making the sugar crystals is very similar to both of them again. So the first step is to create a saturated solution using 1 cup of water and half a cup of sugar. You have to stir it until no more sugar will dissolve, and continue to add sugar half a cup at a time to ensure that the solution is saturated. There will be about 1.5 cups of undissolved sugar. To make a super saturated solution, heat the sugar mixture until it boils, stirring the whole time. Turn down the heat and keep stirring until all of the sugar dissolves. Turn off the stove as soon as the solution starts to look clear. Allow it to cool down and pour the solution into jars, and place sticks in the jars that already have sugar stuck to them. You should start to see crystals growing on the sticks after a few days. By the end of 1 week, there will most likely be many crystals. Although the materials used in this process are much different from the ones that we used in lab to make our alum crystals, the general chemistry is essentially the same, just in a different order. Similar to the step in lab when we used a hot plate to increase the temperature of our solution as well as a stir bar to dissolve all the aluminum hydroxide, the rock candy process involves a super saturated solution when you heat up the sugar mixture to allow all of the undissolved sugar to dissolve. Our final step involved a saturated solution, as we added just a bit more than the amount of solid needed to reach saturation to make sure that we were dissolving as much solute as possible, and we just filtered out the remaining undissolved alum. The sugar crystal process also involves a saturated solution when you add so much sugar to the water that it cannot dissolve anymore. The sugar on the sticks are called seed molecules, and the crystals are formed when sugar molecules in the solution attach themselves to these seed molecules.